Hi, I'm Dr. Nadine Chapman from the University of Sydney, and I work on Plan B, Australia's honeybee genetic improvement program. What's different about this breeding program from what's come before is that we don't have just one population of bees that we're working on. Bee breeders from around the country can collect data on whatever traits they're interested in, and they submit that data to a database. So it's a countrywide program. Now, the kind of data that we're looking for is of three types. The first is performance. So that's how the colonies perform for whatever traits the bee breeder is interested in. The pedigree, and this is in the form primarily of Queen Mother ID. Or we can also do genetic testing so that we can work out how different colonies are related, or how the queens in those colonies are related. And finally, there's the environment. So which apiary the colony is in, the load that colony belongs to, the date of the inspection, and how old the queen is. Now, why we want that information is that we want to be able to pull out for each trait how influenced it is by genetics. So there is an effect of both genetics and the environment on performance. And if the effect of the genetics is very low, like on the left there, then that makes it very hard to select for that trait. So each one of these 5 circles here represents a different trait. On the left, it would be hard to select for that trait because there's only a small effect of genetics, whereas on the right, there's a strong effect of genetics, so it would be much easier to select for that trait. Instead, you could think about this as the same trait measured in 5 different populations. In some of the populations, it would be difficult to select for that trait, whereas in other populations, it would be easier to select for that trait. And if you think about this as a population of black cats, so every single cat in that population is black. And they get that obviously from their parents. There is a genetic effect on that trait. However, because there's no genetic variation in that trait, you can't select for a different coat color. So while there might be genes that control a trait, if there's no genetic variation in a population, then we won't be able to select for that trait in that population. Now, what we do with all of this information is we put it into the database and then we analyze it. And the database will spit out estimated breeding values. And that gives you the genetic merit of each queen. And here I've given some example estimated breeding values for 4 different queens. And I've chosen 5 different traits. And these are just to give you an idea of the different methods that are available for measuring traits. So for the first one, we've got honey. And you can see here, the first queen, she's got plus 18 kilograms. So that means that this colony has produced 18 kilograms more than the average for that apiary at that time. Whereas the next one's got a -3, so it's below average. The next example I've got here is aggression, and that's measured on a score of 1, which is low aggression, to 5, which is high aggression. So the first queen is scoring 2 points higher on that scale. She's more aggressive than the average colony assessed in that apiary. And then the bottom one here is scoring 1.5 below the average of the colonies assessed in that colony, in that apiary. My next example is hygienic behavior. So this is an example here where we've got an area of brood which has been killed with liquid nitrogen. And then you come back at a certain period later to determine how many of the dead brood the colony has removed. So this is measured as the percentage of the dead bees that have been removed. And the first queen is average. So her colony has removed an average amount of dead brood, whereas the next one has removed 6% more than the average, and the one after that is 12% less than the average. My next example is Varroa infestation, which here I've measured as the number of Varroa in a sample of 100 bees that have either been sugar shaked or alcohol washed. And the first queen, her colony had 1 more Varroa than the average, and the next one 2 less than the average. And my final example is brood area measured as the frames of brood. So that's to the nearest 5% of a frame. And the first queen's colony has got 3.5 more frames than the average in her apiary, whereas the next one's got negative 4.13. So she's got 4.3 less frames of brood than the average. And so when you're looking at this, you won't all agree which is the best queen. If you're interested in just honey production, you'd probably choose queen 1. If you were interested in just aggression, you'd choose queen 2. But if you were interested in Varroa infestation, you'd choose queen 4. So not everyone will agree because we all have different ideas about what we want in our bees, and it all depends on our breeding objectives. And a breeding objective is what traits you want to select for, whether you want to increase them, decrease them, or make them average, and whether you value some traits more than others, so what weight you would put on a trait. And Plan B would really like to hear about your breeding objectives. It will help to drive the program, and also we can get that information back to queen bee breeders so that they can tailor their programs for their markets. There's just 3 questions. We want to know what state you're from, how many colonies you have, and what your breeding objective is. And you can get it on either this website or from the QR code. Now, if you want to hear more about Plan B, we're active on social media. So we've got Twitter, Facebook, LinkedIn, and Instagram now. You can also find information on the AgriFutures Australia website. And if you're a queen bee breeder wanting some assistance to do some hive evaluations so you can get your data in the database and start getting estimated breeding values, then you can fill in this questionnaire. Give us a little bit of information about yourself. Thank you.